Hi everyone, Assalamu alaikum. As requested, this is the video on trigonometry for right angle triangles. So, it's not really a very difficult topic, but a lot of people make a lot of mistakes on this. So, what I'm going to do is show a step by step way of trying to solve these questions. So, when I have a right angle triangle, the first thing I'm going to do is label the right angle triangle. To do this, what I'm going to do is locate the right angle first. So in this triangle, that's my right angle. Now once I've done that, I am going to find the side opposite the right angle, and that is going to be my hypotenuse. The hypotenuse is the longest side in a right angle triangle, and it's always opposite the 90-degree angle. Generally, in every single triangle, the largest side is always opposite the largest angle, and in a right angle triangle, the largest angle is a 90-degree angle. Okay, now there will be an angle in the question which will be marked, and in this case, suppose it's this one here. So the other sides will depend on the angle marked. So suppose this is this angle marked. I'm gonna go opposite this. That's gonna be my opposite side. The third side is gonna be my adjacent side. Okay, the three trigonometric ratios we're going to be looking at. So we're going to be looking at the sine ratio, sine ratio can be written as sine theta. Theta represents the angle, and that is equal to opposite over hypotenuse. And I use a triangle for the sine ratio, which basically looks a little bit like the distance speed time triangle. Looks like this one, SOH. Then the cosine ratio, and cos theta, or cos of an angle, is going to be the adjacent side over the hypotenuse. And this is the triangle for the cos ratio. The last one is the tangent ratio. And I'll write it as tan theta is equal to opposite over adjacent and that's my triangle. Now what I'm going to do is I am going to go over some examples to show how we can use these triangles or the formulae to try and find missing lengths initially and then missing angles. So let's look at the examples. So I've got a question here. Let's mark that as number 1. Right, so I've got to first label my triangle. So find the 90-degree angle. Let's go opposite that. That's your hypotenuse. Then we go to the angle that's marked, which is this one. Let's go opposite that. That's your opposite side. The remaining side is your adjacent. Alright, so now I'm gonna write down my 3 triangles. And then I need to make a decision which ratio do I choose. So to make that decision, I'm going to go to the question. I have the adjacent length, the angle, and I need to find the hypotenuse. So I need to go into these ratios, the three triangles, and find which one of them uses the adjacent and the hypotenuse. So let's look at the first one. The sine one has opposite and hypotenuse, so I can't use that. I need the adjacent and hypotenuse. I'll go to the cos. Cos has adjacent, it has hypotenuse, so I'm going to use that. The next step is I need to see which one is missing. So in this case, the hypotenuse is missing, so I'm going to cover the hypotenuse in the triangle and rewrite it as h is equal to a over c. Now I'm going to substitute in what values I have. In this case, h is x. If h was not given a letter, I could leave it as h over here, but since it's given the letter x, I'm going to write down the letter x. A is the adjacent length, which is 8 centimeters, and c is the cosine of 53. I'm going to type in this value or this fraction on my calculator. And my answer is 13.3 centimeters to 3 significant figures. Okay. Excuse me. Right. The next example, again, I need to locate my 90-degree angle first, so it's going to be here. The side opposite that is my hypotenuse. Then I'll go to the angle marked. The side opposite that is my opposite. The remaining side is my adjacent. Again, now I need to make a decision. I need to find the adjacent and the hypotenuse. We're looking at cos again. This time the adjacent is missing, so I cover it and I write it down. So A equals, now if I cover it, it looks like C times H, but I'm never going to write it as C times H. I'm always going to write it as H times C. The reason for that is it prevents me from making a mistake on the calculator. I'm going to substitute values again. So A is Y in this case. If there was no letter Y here, I could write it as A. That's not a problem. H is 10 centimeters, so I'll write 10, and C is cos 35. Type that in the calculator, and to 3 significant figures, my answer is 8.19 centimeters. There we go. Okay, so that's example 2 done as well. We got example 3. Again, label it 90 degrees. Find your hypotenuse. Go to the angle. That's your opposite length. And the third one is adjacent. Now I need to make a decision which ratio to choose. So I've got my 3 triangles which I am writing down. I'll try and do this quickly. So I'm going to use this time I need to find the opposite, and I've been given the hypotenuse and the angle, so I'm going to use the sine ratio. Because I need to find the opposite, I'm going to cover the opposite, and so that's going to be opposite is equal to hypotenuse times the sine. Hypotenuse first, so O is O is x in this case. If there was no letter there, I could write it as O, That's going to be 15, the hypotenuse, times sine 28. Again, type this in your calculator, and to three significant figures, that's 7.04 centimeters. And that's example 3 done. I'm gonna do number 4. I've got, I think, 9 examples here, to give you different scenarios, so hopefully that would help. Right, again, first locate your 90-degree angle. The opposite side to that is your hypotenuse. Then you go to the angle as suggested in the question, marked in the question. Then opposite that you have the opposite angle, and then they are adjacent. Right, so what do we need to find in this case? We need to find the hypotenuse, and they give us the opposite, so we're still using the sine. So I'm going to cover the hypotenuse, and that's opposite divided by sine. So let's write that down. And the hypotenuse in this case is y, so I'm going to write y there. The opposite is 8, and sine of the angle is sine 40. Type that in my calculator. That gives me 12.4 to 3 significant figures, centimeters I should say. Okay, we'll move on to the next 2 examples. So I'm hoping you're getting the hang of this by now. So that's number 5 and number 6. Okay, so in number 5 we label it. Again, you find the 90-degree angle first. Side opposite that is the hypotenuse. You go to the angle, shade it in. Side opposite is the opposite, and you're left with the adjacent. So I'm going to write down my 3 triangles. Not very good at drawing these triangles. Okay, so and the last one is okay, Toa. So in this case I have the opposite and I need to find the adjacent. Opposite, I have the angle, I need to find the adjacent. So can't use sine, can't use tan, can't use cos. I can use tan because tan uses the opposite and the adjacent. I need to find the adjacent, so I cover the adjacent, and adjacent is the opposite divided by tan. In this case adjacent is x, the opposite is 5 centimeters, and tan of 60 degrees. Write this down on your calculator. And that's 2.89 to 3 significant figures. Right, and there's another example here, number 6. So we first locate the 90-degree angle. Side opposite is the hypotenuse. Then we go and find the angle. Side opposite that is your opposite. The remaining side is your adjacent. Okay, so this time we have to find the opposite and we have the adjacent. So tan uses the opposite and adjacent, so we go to that, we cover the opposite because that's the missing one, and we write it as opposite is equal to adjacent times tan, not tan times adjacent, again to prevent any mistakes. So opposite is m, adjacent was 7 times tan 37. which is 5.27 to 3 significant figures, 5.27 centimeters. Okay, that's how you'd find missing sides. The next thing is to find missing angles. So in order to do that, we have the same sort of process. So first locate the 90-degree angle. That's your hypotenuse. The angle in question, that's your opposite. And the remaining one is your adjacent. So this time I have to find a missing angle. I have been given my opposite and hypotenuse, so that is the sine ratio. Since I have to find the missing angle, I'm going to cover the S over here. So I'm going to have S is equal to O over H. So I'm going to write that as sine X. The opposite is 4 centimeters and the hypotenuse was 7. Now in order to find a missing angle, we will use the inverse of the ratio. So I'm going to write this as X is equal to inverse sine, and we only use inverse sine, inverse cos, inverse tan when you're finding a missing angle. Missing lengths don't use inverse sine, cos or tan. Right, and I'm going to type this in my calculator. That gives me 34.8 degrees to 3 significant figures. Now we'll look at our next example. This is number 8, I believe, and there is one more, and that would be all. So first step, locate the 90-degree angle, label your hypotenuse, then you locate the angle in the question and find the opposite side. That's your opposite side. The remaining side is your adjacent. So this time I've got the adjacent and the hypotenuse, and that is the cos ratio. So I need to find the missing angle, so I'm going to cover cos. So let's substitute in the values. Cos y is equal to adjacent 5 over 12. So in order to find y, I'm going to do the inverse cos of 5 over 12. That's 65.4 degrees to 3 significant figures. And the last one, again I have to find the missing angle M, so I'm going to label my hypotenuse first, opposite the 90-degree angle. That's the angle in the question. So that's my opposite side, that's my adjacent side. This time I have an opposite and an adjacent. I have to find the angle, so that's the tangent ratio. I'm going to cover T because I have to find the angle. So T is equal to opposite over adjacent, and that's going to be tan of M is equal to the opposite, which is 6, over the adjacent, which is 4, not 5. So to find M, I do inverse tan of 6 over 4. Type that in my calculator. And I get an answer of 56.3 degrees to 3 significant figures. There we go. So it was a bit of a lengthy video, but I hope it helps you solve questions on trigonometry with right angle triangles. Thank you for watching, and all the best for your exams.